Hi and welcome to madCAM for Jewelry. In this lesson we will talk about various strategies, multi-axis strategies that you can use to produce your jewelry pieces. We'll start with the simplest of 2D engraving style paths, going on to slightly more complex 3D, 4D, and then finally 5-axis simultaneous cutting. So let's begin. Let's say you have a simple dog tag-like object. Medallion perhaps with some engravings, and all you need to do is engrave design that is on a uniplane and consists of a bunch of curves. So to do that, first of all, we position our object in an appropriate way in Rhino space. To do that, as you might recall, you need to select the object, select cutter, and then click preview. As you can see, this orientation is good for a 5-axis mill because the arm can turn up a 90-degree angle and then this piece will lie flat. On the subject of tool cutters, by the way, for 2D operations I recommend creating a separate copy of a cutter with a slightly slower feed speed. This will assure that your two-dimensional cut will be nice and clean. Now go to make sure you're in the 5-axis tab, click our 5-axis option, and make sure that the active plane is selected. If it's not, you might get incorrect results. And to make sure that we're cutting from the right direction, you have to examine our top view. Top view is how your cutter will see the model beneath it. So it's sort of like looking from top down. If you see this sort of a picture, then you're in the correct position. If you see something different like this, you're not in the right position. So make sure you find the right C-plane for your cutting. Once you're in the correct setup, select your curves, go into curve milling, and click along curves. Here you can specify a few options. Multiple Z cuts will allow you to set up a toolpath that doesn't plunge all the way down to its final level, but rather steps down in increments. This is not a bad idea when carving deep paths. So, for example, we can make sure that each segment is done in 0.2 of a millimeter. This will ensure that the wax is really cleaned out well as it goes down. We can let madCAM optimize the curve order for speed, or we can let it respect the Rhino curve order. That's up to you. And finally, we can define a safe clearance if there are segments of the model that are not actually either included, or for some reason you have some boundaries that are not accounted for. In this case, we'll leave it as default. Same goes for ramp depth and angle. We will leave those at default for now. Click OK, and you will see that madCAM has added these lines which are representative of the toolpath. Little orange segments are your faster movements. These are your rapids, and this blue triangle, or this 90-degree looking thing, is your starting point. So when you look at this path, what it's saying is that the bit will come down this way. It will do its tracing of, say, the 2, come up, do a rapid, come down to D, come up again, and so on and so forth. So to view it on a simulator, click the simulate button. Make sure your speed is all the way at the slowest end, because the 2D paths are very quick and will zoom right by you. Click reset to make sure it's primed and press play, and you'll see your initial movement. So now our A-axis is lined up, and you'll see the tool bit tracing our paths as well as our rapids. So fairly straightforward. There you go. Now, if you want to be extrajudicious, you can duplicate this path, meaning that once the initial carving has been done, the bit will return and retrace all of these steps. That will make sure that if there's any kind of clogged wax in these areas, it will clean them out. And to do that, you don't really need to recalculate the toolpath. All you have to do is just copy and paste this object, because this is just a Rhino object. It's a collection of curves. And so all you have to do is Control C and Control V. And now when you click on it, you'll get this little duplication. And when you view it in a simulator, and I'll speed it up for the sake of explanation, you'll see that it does its initial cut and then repeats the exact same cut. Generally a good idea for any kind of engraving type of work. So that's your simple 2D operations. Now, for something more elaborate, like 3D operations, we have a little extruded dog tag or medallion or whatnot. And we begin the same way. We select the model, we select the bit. In this case, we can do our regular bit with our 300 to 350 millimeter speed and do a preview. This looks good. This will work. For a 5-axis positioning, we just have to make sure once again that this is aligned to the way that we want it. So I'm going to go with 5-axis option, select from active C-plane, and select an appropriate C-plane, such as this one. Now, in order to cut this out, since it's now a 3D toolpath, we have to create an additional boundary curve to define exactly what area we're going to be cutting. So let's say we want to cut out just the letters. Then the boundary curves can be made from outlines of these letters. But if you want to cut out this entire object, then we want to put the curves around this whole area. So let's say we're going to do that. We're going to use this whole object as our boundary. So one of the easiest ways to create boundary curves is to perform a silhouette command and followed by curve boolean, delete all the input and click outside. All this does is it just gets rid of any of the extra junk, keeps everything in the one dimension, and creates us a nice boundary curve around this object. As you can see, it's drawn right around the 0 point. So now to have our boundary, we'll go here, once again the 5-axis curve cutting, and select 5-axis from boundary curves. Here we have a slightly different set of options. First is the stock to leave, a fairly straightforward option. If you're doing this as a 2-step operation, for example, a roughing pass followed by a finer pass, you can select to do this. You can change the mills for milling bits rather in between, or you can elect to choose a stock at 0 and cut right to the final model. Second, and another very important option, is the step size. A step over size is essentially your resolution in cutting. So the finer, the smaller the step over size, the more precise and smooth your model will be. I recommend using 0.03 as a general starting point. For really rough cutting and quick cutting, you can do 0.05, and for really fine cutting, you can do 0.02 or even 0.01. In my experience, when casting, you will likely not be able to see less than 0.02 of a millimeter. You will definitely be able to see the step sizes above that, but in some cases that might be okay for flat surfaces, for surfaces that you're trying to polish away and the like. And that decision is up to you. It depends on how much you are planning to work with a piece afterwards and how much you need to keep the cleanliness. In this case, we will use a resolution of 0.05 simply because it's a quick test and it'll give us an idea of how this will look. Finally, we have the link method, which is also quite important. We have option of zigzagging along X, zigzagging along Y, contouring, or V-carving. These terms X and Y are a little bit misleading. They really refer to the X and the Y as seen from the top-down window. So in this case, if we select the zigzag X, our mill will move its bit this way. If we choose Y, it will move its bit this way. If we choose contouring, it's gonna start either on the outside, working in spirals towards the center, or in reverse, starting from the center, moving in spirals towards the outside. V-carving is gonna be something a little bit different, so we will discuss that at a later video. For our purposes, we'll choose zigzag X. The choice between zigzag X and Y is entirely up to you. I quite commonly prefer zigzag X, simply because it moves from side to side, moving towards the stock or my support, if my support is here, for example. But people can elect to choose the Y movement as well, and that will work just as fine. So we'll pause the video for a moment while it's calculating. And here we are. So the tool pathing calculation finished, and once again we see a similar picture with our starting point, the entry point if you will, indicated by this right angle blue thing, the descent, and then beginning of a tool path. Every bit pass is marked with a line. The connections, as you can see, are these squares, and you can see that as it approaches, it starts to pick up and cut around this extruded area. If you're wondering why it has a little bit of space around these letters, that's because we have a tapered 5-degree bit that is specified, so it comes at an angle, and so this is the closest it can get without starting to cut away at this model. So as you can imagine, as a result, these extrusions will be a little bit tapered. There are ways on 5-axis mills to clean this up as a separate operation and make sure that all of the angles and walls are perfectly straight, but that's something we will discuss at a later point. For now, we can run the preview. So again, press the reset button for the first time and press play, and you can see the mill bit doing its thing. You can speed up our simulation and watch it from different angles, and yeah, you can see it doing its 3D cutting from curves. So that's our 3D cutting. Now, moving along, let's do a 4-axis cutting. So 4-axis basically refers to rotary style cutting, whereas in 3D style cutting you engage 3 axes, the X, the Y, and then the Z to go up and down. 4th axis strategy allows you to rotate the piece as it's performing all of those other 3 movements. So let's say we have a ring like this. The most A sensible way to cut this ring is to simply put it on a virtual spit of sorts and rotate it as we cut the surface. So let's do our usual selection of a bit, and preview. Here it's very important that the ring itself lies parallel to the chuck, because this is the section that's going to be rotating and you want to make sure it's rotating the ring in the right way. So now that that's done, we need to draw a line that represents this rotation axis. So there it is, that'll be our rotation axis. And we need to draw another line that will represent the angle of approach of our bit. That'll be this. Then we go to our 5-axis tools, axis of revolution, and the first option is to pick the axis of revolution. And the second is to pick the spindle axis. With those two selected, we'll click OK, and you will notice that this neon line, you can get rid of this, is now no longer a square but rather a round, kind of hugging shape. Here we can go to one of two options. We can either specify two curves, one on each boundary of the ring to cut between, or we can tell madCAM to use this whole surface of this model as a cutting. So we can try both. To get our two curves on the ring, we can use dupe edge command in Rhino, like so. That'll give us our two lines. And then we can go to, once again, the curve milling menu, and instead of selecting boundary curves, you select between two curves. And once again, we see very similar options. Stock to leave, we'll leave that at 0, and step over size. For the sake of demonstration, I'm going to make it quite large. I'm going to make it 1 millimeter step over, just so it goes a little quicker. And here we go. Here we can see our rather rough looking tool path. So we can actually, since it goes by pretty quickly, we can make this a bit finer, maybe something like 0.2, and we'll get rid of the previous one, and let's do a preview on this. So there's our ring, there's our bit, and you will notice as our cuts are made, we have this axis, in this case the B axis, moving, rotating around. So when it comes to our engraved text there, it will fall in and make these cuts to reflect the engravings. So there's one way to do this for axis simultaneous approach. And the other way, let's just hide this toolpath for a moment, is to use surface milling and specify planar finishing with a similar step over size or something along these lines. Planar finishing has a few other additional options, which we will, for now, set to 0 and leave it be. It produces a somewhat similar result. There are some subtle differences that we will go over in future videos. It does produce a rotary path as well. You can see there's a bit more extra movements there, which we can limit. But it allows us to do that without defining the boundary lines. Of course, this will process the entire model, so you cannot restrict it in the same way as we could with boundary curves. But once again, we will talk about the differences between these two in details. Finally, we have our 5-axis simultaneous movement for more complex things, like this ring. So the reason why we might want to use a 5-axis simultaneous strategy on this particular ring rather than a rotary is because the rotary keeps the its x and y movement similar as it rotates. So we could use a rotary strategy, but we would have to make it the two boundary lines wide enough to encompass both, say, this boundary and this boundary, which means there'll be a fair bit of wasted calculations cutting the space around it. And that's okay, it's just not that optimal. So instead, let's perform a 5-axis simultaneous operation on it and see how that helps us. So as you may recall, I suggested that for 5-axis simultaneous we pick a higher feed speed if your controller is something like Mach 5, Mach 3 rather, and has issues with its feeds for simultaneous operations. And let's make sure we position it correctly. So this is not the correct way to position it. So let's rotate it by 90 degrees, reselect it, and make sure now we're in parallel with our chuck and the axis. So this is looking good. And now we need to go to the 5 extra tab and click on select drive surface. Here we select either a surface of the object or a separate surface which will be used to guide the bit. In this case we can just use the ring surface. Specify calculation height and depth. In this case we just create a little offset above and below. Really we could just use 0, but this is just a little safety catch. And the limit of the angle. This is the maximum angle that the machine will do before trying another approach. So we can leave it as is, or we can leave an arbitrary maximum angle here. And just as we did before, we go to a surface milling selection and choose planar finishing. And once again, we'll enter like something like 0.5, angle limit of 0, and click OK. And what we see here is that it didn't quite do what we expected it to do. So let's make sure we selected our surface correctly and that we're pointing that arrow downwards rather than outwards. So, and we'll also increase the height above and below the surface. Actually, we'll leave the depth below surface at 0 since we really don't need it to go below that. And let's do our milling calculation again. Now that's much better. So you will see that in this case, when we run a simulation, our bit will follow the outline of the ring as it curves around. Keeping to the surface exactly. Now, generally speaking, I wouldn't follow the ring in these lines, kind of following the exact outline this way. I would use a perpendicular approach, meaning that you switch it from parallel to X to parallel to Y, and you'll see what I'm talking about. So basically a zigzagging this way rather than this way. And let's increase the speed a little bit. You'll see that these rather wild movements of all of the axis as it goes. but it will follow the outline of the ring exactly. This is one of the slowest and one of the cleanest ways of cutting really difficult shapes. There's a heck of a lot of movement, but it's keeping the bit as perpendicular as it can at all times, at all angles. There you go. So here you see why it's important to have our ring positioned far enough away from the chuck so that you don't get collisions. And likewise, you see why it's important to have a reasonable angle limit, in this case 130, defined, because any further and then this A-axis will start colliding with the spindle. So that's your 5-axis simultaneous. One more operation that would be interesting to show in terms of simultaneous 5-axis cutting for jewelry is what's known as swarf profiling, and this is very useful for cutting straight walls in rings and other objects. So for example, we can select this inside of the ring and position our bit, as you can see it shows a little preview, in a way that is completely vertical. If you look on in this section, you'll see that even though we're using a tapered bit, by tilting it a little bit, it will be completely vertical now. And clicking OK. It's a very quick way to make these complex cuts. Let me slow that right down. Making these straight wall cuts in rather complex surfaces. There you go. Now the inside of this ring is cut out perfectly flush with the wall. So that should give you a quick overview of 2, 3, 4, and 5-axis operations, and we will review each one of these in detail in the next videos, and we will see how and why each one is appropriate for different strategy and different objects. But meanwhile, this guy gives you a really quick run through the whole of madCAM's abilities. Thanks for watching.